Today's topic is limit of function. First, we will understand what is the concept or what is the understanding of limit of function. Then we'll see the definition and then go to the questions based on the same. So, first, in order to understand what is limit, we need to know two things. One is neighborhood of a number. Say A. So if I am looking for a neighborhood of A, we are looking for values around A, an open interval which includes A. So if for example we have say 1, then the neighborhood of 1 may be 0.5 to 1.5, any open interval around A, or it can be say 0.2 to 1.2. It cannot be that both the sides the value is same, the difference is same. It can be any interval which includes 1. Same way, we have another one, that is deleted neighborhood of the number. So in deleted neighborhood, the only difference is that we will take values around A, but will not include A. Open interval around A, that's what we mean by neighborhood of A, that does not include A. And for an example, you can say if you have 1, you will take value 0.5 to 1 and 1 to 1.5. You are not including 1. In this way, you can take any neighborhood of 1. We did not include 1. This is what we mean by deleted neighborhood of a number. Now, limit is always defined on deleted neighborhood. So, when we say that if I want to find the limit of a function, let's take a very simple one, fx, which is x plus 1, when x approaches to number 1. Okay, so let's take very simple. Let's understand this. By this we mean that we are going to take numbers around 1, deleted neighborhood we are going to take. So we are going to take numbers around 1 and we are not going to include 1. So we can take values which are smaller than 1. We'll take values that are greater than 1 and let's find out what is fx. So I have taken these different values of x which are smaller than 1 and some values which are greater than 1. We have to find fx for this, and so simply put x value in the function and get the value of fx. On finding fx, we see that when x approaches to 1, then fx approaches to, the value you can see is approaching to 2. You take a value which is nearer to 1, say 0.9999, you will get 1.9999, which is again more closer to 2. Same way, let us find for a value which is greater than 1. So once again we see that as this x value approaches towards 1, fx value is approaching to 2. So this is what we mean by limit. We mean when you take values smaller than 1 and see where is fx approaching to, and same way for greater than 1. How do we write this? We write this as limit of fx when x stands to 1 minus. When you write 1 minus, we mean it is x values are smaller than 1. Our value is coming to 2. Same way over here. When we took values bigger than 1, that is x stands to 1 plus, the value is coming to, fx value is coming to 2. Now every time it will not be the same. The value may come different. If the value is same, we say that the limit of the function exists and it is whatever value we have over here. If it is same. Otherwise we say the limit of the function does not exist. And so now going to the definition of limit. So as we saw that values smaller than a are to be calculated separately, we said that if x approaches to a from the left side, that means value smaller than a, and if x approaches to L, it is said that limit of fx when x stands to a. Now we know this means value smaller than a. if this value is equal to L, because we are taking value smaller than A, it is called the left hand limit. In the same way, we can find for the right hand limit. By right hand limit, we mean that when x approaches to A from right side, that is values bigger than A, we take values after A and up to a few values. And if fx approaches to L, we say that limit of fx when x stands to A plus, again this means that values of A are greater than, values of x are greater than A. And if both of these are same, that is when LHL is equal to RHL, we say limit of fx for x stands to A is L.